Hello folks, Candor here. Today's video has been a bit of a frustrating experience for me. In one of my last videos you may have seen me talk about a power supply. My old one, which used to sit somewhere, is over there. A little power supply that could. Now I had originally intended on replacing that power supply, as I had said in that last video. And I was going to build it, and I had something very, very unique. And I was really wanting to show you guys what I had come up with. Unfortunately, it was dead on arrival. And, well, basically after several weeks of going back and forth, I was eventually given a refund for what I wanted. And rather than order another one and wait another ungodly amount of time for it to be shipped over from China to come, I finally gave up on it. But I will show you at least what it is that I had in mind anyway. You see, originally, this was going to be my new power supply, complete with TTL cable. This is the main interface right here. This would have been where the power supply would have plugged in, and also where I would have attached my peripherals. And this is what made it so unique. This is a wireless head control unit that would have allowed me to pretty much control this entire thing wirelessly without having to have all of this on my bench. In fact, the entire idea was to actually have this mounted underneath this very table in the back, and just have the cables coming out from the back and up and over, and just having this sitting down on top of the table and allowing me to control the entire system right from here, from this little wireless control head. But again, this was dead on arrival. It does not work. Unfortunately, I bought a lot of other support pieces to go with this, which I didn't think I was going to need again. But as luck may have it, I found a different solution which, well, not quite as ideal as this right here. I think is going to prove to be a much better solution. So let me show you what I came up with. This is the Riden RD6006W control head unit that I just purchased. And inside here is a very nice control head unit. In fact, in some respects, I like it quite more. Comes with a temperature probe and the control head unit itself. Now, this is not the power supply. This is merely a control head, which will control the power supply. It's a very small, compact little unit. The W in the name refers to the wireless module that is installed. I'll get into this a little bit later. But I'm warning you now that this video might run a bit long. This thing is rather complicated and is quite unique, and to go over its features is going to be quite extensive. But you might be really surprised at what this little thing can do. In fact, when I found out some of the things that it could do, I am actually far more pleased that I purchased this than ended up using the other one, because this actually gives me far better control over anything that I could have ever hoped to have done with that other one. And it's also a bit more powerful. So let me show you the pieces and parts that are going to go together to convert this into my new benchtop power supply. So now that we have a controller, we need a power supply. Now, if any of you out there want to build your own benchtop power supply, the first thing that I would say is to get an idea of what power requirements you're looking for. Most projects may not require more than 12 volts at 5 amps. So if you're looking for something that is variable up to 12 volts, then I suggest one of these, an ATX power supply. These are usually easy to get, a fairly common part to replace if the need arises, and can provide ample current. In fact, my first choice was this exact power supply. I've had this for a while now and used it for various projects from time to time, and I also knew that I wanted USB power. And the ATX power supply just so happens to have a 5-volt rail, perfect for this purpose. Now, two things to keep in mind if you intend on using an old computer power supply. Some older power supplies require a load on the 5-volt rail before it will turn on. So with that in mind, I picked up one of these. This is a 50-watt, 40-ohm resistor. Luckily, I didn't need this, but you also need a trigger to turn the power supply on. For that, you need to ground out the green wire, which I think is pin number 13, which should be right here, if you can see it. This green wire right here needs to be grounded out to any one of these black ground wires. So to save myself the hassle, I also purchased one of these. Now this is an ATX breakout board. You simply plug this cable into it as if you were plugging in your power to your motherboard. And what it does is it gives you access to all the power rails, like your grounds, your 12 volt, your 3 volt, your 5 volt. It also gives you access to a switch that will trigger the power supply to come on. And it also gives you the ability to add a remote switch in the event that this is inaccessible. But I also knew that I wanted USB power. And this also happens to have a USB socket on it. Perfect. In my case, I was really only interested in this and this. I, however, also needed more power. But Candor, you only have 12 volts to work with. Yes, you are correct. But to remedy this, I bought this little unit.
What is it?
This is an 1800 watt DC to DC booster. And since the power supply can give me far more current than I need, this little unit right here gives me the advantage of converting that unused current into voltage. Since I can only draw 6 amps with my controller, the other 12.5 amps was being wasted. But now I can convert that wasted current into voltage. Using this little booster, I can up my voltage from 12 volts to 40 volts at 6 amps, giving me a total of 240 watts of power. A decent consumer-grade purchase benchtop power supply can run $75 to $100. Remember, I said decent, not cheap. And I still only get about 30 volts at 5 amps or about 150 watts of power. And no guarantee that power supply will be properly shielded from RF noise. To that end, I also bought one of these. This is an inline filter just for that. I never did ever need to use this. With the parts that I ordered, I paid about $145, but ended up with a much more powerful power supply and features you can't normally get from a pre-made one. But since I only used a few of the parts I bought, the price was closer to $105. For what I actually needed anyway, because since the RF line filter, resistor, and ATX breakout board weren't used, I saved some money. If you already have a power supply and you feel comfortable with that it supplies you with the power you need, then the controller may be the only part you do need. My last power supply happened to just be an HP laptop power brick. I had one of these laying around. This gives me 18.5 volts at 6.5 amps. Now if you need to boost the power, you only need the controller and a DC booster. Now together those two parts cost me about $98, but I could have opted for a smaller DC booster and saved a few bucks. In the end, I changed the design considerably. After I wired the ATX power supply and got everything assembled and ready to test, this happened. It should all work.
Fiddle faddle.
It should all work. Eventually, I did get it up and running. Ta-da! Well, it took an embarrassingly long time to realize that the remote module I was using had died and wouldn't activate. Shortly after that, a good friend of mine said he had a better power supply and shipped it to me. I received this. A very nice adjustable power supply capable of up to 540 watts of power. The DC booster allowed me to increase the voltage to 60 volts at 6 amps for 360 watts of usable power. Plus, it also gave me an additional 60 watts to spare in the future should I need it. Now, because I ended up using this new power supply, I no longer needed the ATX breakout board, resistor, or the inline filter, since the new power supply has all that incorporated into it. However, this also means that I no longer had the 5-volt rail for my USB connector. Not to worry, I had that covered. I have another part coming that cost me like $2 and change, and it's going to give me 5 volts at 3 amps, which is more than the ATX breakout board gave me. This allows me for fast charging my cell phone now. Now, before we get into the controller interface, just know that this video has seen many revisions, retakes, and alterations, so you might see some time and date and other anomalies. So let's see how this thing works, shall we? Now that we have a fully functional power supply, let's go over the main interface a little bit. On the left-hand side, what you see is this is where you would see what the unit is currently outputting when you press the on and off button. On the right-hand side, we have what you currently have the unit set for. Currently, I have it set for 35 volts at 5 amps. This is my over voltage protection, my over current protection, and this is the input voltage, which is actually supplying voltage to this unit. I have currently upgraded this to a 360 watt power supply from the 200 watt power supply you were just watching me assemble earlier on in this video. I had a friend of mine who was gracious enough to send me a really nice power supply that boosted my power nicely. Thank you very much. Down here is where you would use this to set your current. You would use this to set your voltage. And once you press these, you'll see that the numbers light up. And you can use the arrow keys to select which digit that you want to change. And you can use the rotary encoder knob, or arbitrarily, you could just type in any numerical value that you wanted. And once you press the on and off button, it automatically kicks in and shows you that right now I am pulling 9 volts, almost 10 volts at 1.37 amps and 13.67 watts with this current coil that I have right here, and that's actually getting a little bit warm. One other thing to make note of is you'll notice that we have 3 banana clips or terminals here. We have a black, a green, and a red. Now, most people would assume that this is a ground. That is not a ground. This is for battery charging. Yes, this little unit does have built-in battery charging functions for many different types of batteries, LiPo packs, lithium-ion packs, lead-acid batteries, etc. As long as the battery that you are charging does not have an internal battery management system, you can charge a battery with this device. This is where these numbers right here come into play. You'll see that it alternates between temperature, amp hours, and watt hours. It really only has merit when you are actually charging a battery. So these numbers down here don't really mean anything if you're not charging a battery. This is the setting screens. There are 4 sub-panels to this setting screen. The main screen right here is basically where you select the basic operating functions of the unit, such as which language you want, the brightness of your backlit LCD screen, whether or not you want the boot logo to show, whether or not you want this to beep every time that you press a button, which interface do you choose to use. Right now it's set for USB. You could also set this for Wi-Fi if you had the Wi-Fi module installed. This is where you would select the actual display. Now, when it first turned on, we saw that we were in the digital display, but you could very easily set this for a graphical display, and now you can see we have a graphical readout rather than a numerical readout. I don't really often use this very much. The third sub-panel is where you set your memory locations. Memory 0 is pretty much the default. Memory locations 1 through 9 can be accessed by pressing the Shift key and the 1 through 9 buttons. So you can change those by pressing your Enter button, using the arrow keys to select which one that you wanted and going in and then pressing, changing the values to whatever you want. And in this case, memory location 1 for me happens to be set for 35 volts at 5 amps. The last sub-panel is pretty much where you see your product model, the product serial number, the firmware version that you are upgrading to or currently running, and the temperature of the internal device itself, not the temperature probe. This is independent and only used primarily when you're doing battery charging. In order to recall a memory function, as I said, you would just press the Shift button and whatever memory location you want. You can see that this is set for 35 volts at 5 amps now. That's what I had set for memory location 1. When you turn on the power, it instantaneously recalls that and starts ramping up. And as you can see, it is glowing quite warm. Well, how hot is this, you say? I'm only pulling 160 watts. I still have 200 watts left over of available power. But this is still powerful enough to light butane instantaneously.
Now, up until now, I've been kind of rushing because I wanted to get to this. This is the software that you can run to control your controller. And this is what basically makes the controller so invaluable to me. At current, you'll see that I am using the USB connection. I could also opt for Wi-Fi. You can run this on your PC, you can run this on your iPhone, you can run this on your Android phone or tablet. I've chosen USB only for one very specific reason. There are certain functions that you cannot perform while using Wi-Fi. Another thing to note is I have seen the mobile application, and quite frankly, I find it lacking compared to this right here. What we have right here is, when I showed you before, we went from the digital display to the analog, or the graph display, which is basically what we have right here. And you can see it changing in real time. And it's as over time, the graph will basically show you what your current is, what your voltage is, what your wattage is over a specified time. Down here we have what your voltage is currently set for. Currently it's set for 35 volts. Now you could change it by clicking these buttons right here, selecting which one that you want to change, or arbitrarily again you could just type in whatever voltage you want. The dial does not actually physically function as a way to control the inputs. It's just there to give you a visual representation. And as this changes right here, you'll also see that the dial will change also to show you the gradient of the dial to the maximum. Currently, I am capable of running at 60 volts. That's why it's at 60 volts. Over here, we have the current. Right now it's set for 5. I could go for a maximum of 6 amps, but I'm only running at 5 amps right here. Earlier I discussed the battery charging. This right here is where it would show you all of the battery charging functions and features. This is where it would show you what the voltage is that's going into the battery. And using the temperature probe, you can actually place it on the battery to keep an eye on the temperature to make sure that you're not overcharging or your battery's not going into a thermal runaway. And it gives it to you in both Celsius and Fahrenheit at the same time, which is actually a nice feature. It also will tell you your output amperage hours and your watt hours, just like on the main display, but it gives it to you all in one place right here, easy to see. These are your data locations, which you can easily go through and recall it anytime you want. As you can see, my data location 1 is set for 35 volts at 5 amps, and should I hit sure, then I can recall that, and then sure enough, there it is, it's 35 volts. time synchronization allows you to synchronize the time between the control head and your PC. So in the event that you need to make a log, they'll both be synchronized. You can also change the backlight LCD to whatever it is that you want. You can make it dark, you can make it bright. Currently I have it set to about 3. That's about a good brightness level for myself. On the right hand side over here, we have, this is the input voltage. Right now my power supply is supplying approximately 63 volts to my control unit. As soon as I press the on button, you will see that it will give you the actual output voltage, the output current, and the output power in wattage that we are currently pulling. The system temperature, again, is for the internal control head. This will only show you how hot the control head is getting to give you an idea of whether or not you're overheating your control head. As you can see that your graph over here does display in real time your output voltage and your output current. Now should you need to, you can right click and you can actually export this either to an image or to an Excel file. So now you could actually export this to an Excel file, bring in the data, and actually graph it in a pie chart or a line chart or whatever else that you need to do. Or if you need to, you can just hit clear and it will erase everything and start over fresh and clean. The advanced functions, however, are where this shines. This right here makes the purchase of this control head absolutely perfect for me. This right here allows me to program a specific set of pre-programmed or manually programmed steps in both voltage and amperage over time. I have a specific project coming up, which is a resistance project. This will allow me to say, okay, in this specific instance, it starts out at 10 volts at 1 amp and will last for 5 seconds. After that, it ramps up to 15 volts at 2 amps for 5 seconds. Then 20 volts at 3 amps for 5 seconds, 21, 3, 5, 24, 4, 5. And it will continue on through whatever I have programmed here. And you have quite a large number of steps that you can actually program into this. So I can program this for a specific ramp up time, and after it gets to that, I can say, okay, I need you to hold this for X number of time before you stop. This area right here pertains to how many times the cycle times, how many times it's going to cycle through the programmed set that you have over here. What number you want it to start at. In my case, it's going to start at step number 1. And where is it going to stop? It's going to stop at step number 10. It's going to repeat that 1 time, 2 times, 3 times, 4 times, whatever I choose and whatever I want. If I hit start, it will automatically start and go through, and it will hold that there for 5 seconds, and then after 5 seconds it will go to the next step of 15, and it will continue on through the entire cycle. You can pause it and you can end it anytime that you want. Manual mode, basically what that allows you to do is, rather than having it automatically step from one step to the next step to the next step to the next step, you can manually select and hit the next button to advance it manually to the next step that you choose. And down here it tells you what current cycle you're on, what current number you are, and you can save this to a local file if you so desire and so need. When you're done or it finishes, it will just complete its task and it will stop and go. And basically you'll have an entire graph right here of what happened. Voltage scanning and current scanning. These are advanced functions that most people will probably not ever use. Voltage scanning basically allows you to set an output current. We'll say 5 amps at this point. I want to start at 1 volt. I'm going to stop at 35 volts, and I need you to advance and say 1 amp increments. And I want you to hold that for 5 seconds. When I hit run, what this will do is it will start at 1 volt and it will tell me what the current is. It's now at 2 volts and it will tell me what the current is. And it will continue on until it hits this output current or it finishes this cycle, whichever comes first. This will allow me to figure out at what voltage I can expect to be able to pull 5 amps on whatever circuit or whatever I'm working on. The same thing goes for the current scanning. This allows me to decide to figure out at what voltage I'm going to, or what current I am going to be able to pull at what voltage. It's just the opposite of the voltage scanning. So instead of stepping up the voltage every step, it's going to step up the current until it reaches whatever I put into those parameters. If you should happen to have the alternate RS485 multi adapter into it, you can control this through that interface. I do not have that. I cannot control it that way. Firmware update. The firmware update will allow you to update your firmware on your machine, so if you need to. When I first got this, there was a firmware update. It will tell you where to go and how to download it, and then you can upload it from here. Their website's a little bit slow. It could take a while if you so desire to do that. You don't have to if you don't want to, but I did. Again, this is one of the features that you can only do through USB. You cannot do this through Wi-Fi. The other nice thing is the startup logo. Yes, my friends, we can select our own boot logo. And when I hit picture import, it will automatically start and upload the video or the picture to the boot logo. And now we have a boot logo we have just uploaded to the machine. And to give you an idea, the next time that we reboot our unit, we should have a new boot logo. Ta-da! This is really nice, especially if you're going to be working in an area where, say, you are a business and you want to either have your company logo on it or, for whatever reason that you want. For mine, it's just for laughs and giggles, but it's a nice thing to be able to do. Now, I could go into a whole bunch deeper into all of this, but for the sake of time, I am not going to go much further than this. If I should happen to hear from people in the comments that they want to know information more deeply about what this is capable of doing, I might actually do another video with a little bit more in-depth to it. But I just wanted to give you an idea of just what it is that you can expect to get from something of this. For about the $79 that I paid, I am very happy with this. Now, I'd like to apologize for just how long this video has become, but I think you can understand why. There's a lot of features inside of this little unit right here, and it would just take far too long to go over everything. And there are a few things that I didn't even get to cover the way I really had wanted to. Now, for the money that I paid for this, I'm very happy. The very first one that I showed in the very beginning with the wireless controller didn't cost much less than what this one did right here, and this one far surpasses anything that I could have hoped to have done with the other one. If you're looking for a benchtop power supply controller or to just build your own benchtop power supply from scratch, this might just be the way to go. It's feature packed and it is not overly expensive. And you can actually buy this as a complete kit online with the controller, a case, and a power supply. Now, I'd like to thank all of my viewers and all of my subscribers, because without you, I'd have no reason to make these videos. So, as always, I would like to thank each and every one of you, and I hope that I'm going to be able to continue bringing you videos that might interest you in the future.
So until next time, guys, thank you for watching, and I'll see you in the next video.